Today, there's an impressive array of wind turbine designs, very small ones on the order of 30 feet, and ones that can be several hundred feet tall. I think future wind energy is probably going to take a couple of different paths. One of the prominent ones is moving offshore. You get a steadier wind and often a stronger wind. It also allows us to put turbines out of view, frankly, so people aren't worried about the visual impact of the systems. And we can make them quite large. GE has just in the past couple of years unveiled a 13 million watt wind turbine. It's a huge amount of power that these systems are able to generate. The challenge with those large systems is twofold. One is the expense of those very large systems, and the second is the transmission of that power to the end user. In the United States and Europe, we have the capability to transmit that power. In many communities, they don't have access to that type of grid infrastructure. And so some of the larger systems that require transmission over long distances on high voltage, while they're going to be a wonderful way to offset carbon emissions in wealthier countries, they're not really going to move the needle in the near term in other areas, which incidentally are the places over the next 10 to 50 years that will be increasing their energy consumption as their standard of living increases. One of the technologies we're interested in developing are these smaller distributed wind energy systems, which can be equally applied in Pasadena as in rural China. The benefit of these smaller systems is that the local community can take a part in building them, in installing them, maintaining them, and ultimately in consuming the electricity that's generated by them. And they can do it without grid infrastructure. In our lab, for example, we've developed systems that are called vertical axis wind turbines. Instead of blades rotating on a horizontal axis parallel to the ground, they rotate around an axis that points straight up out of the ground. And those vertical axis turbines, we found, can make better use of the wind as a group than the individual horizontal axis wind turbines that we're more commonly using today. So you can get up to 10 times more energy out of a plot of land using this approach than the conventional systems. The other important aspect about these vertical axis wind turbines is that they're smaller physically and the blades rotate at a slower speed. This is important for the visual impact so that it's less objectionable to people as far as having it close to the built environment. And it also tends to be safe for birds and bats. An exciting place where we're able to demonstrate the vertical axis wind turbines is a fishing village in Alaska. It's a community of only about 70 people, and they currently rely on diesel fuel being flown into the village because of their remote location. That is a high cost for them, so they pay much more for their energy than we do in the lower 48. And of course, the fuel itself is quite polluting. At the same time, the village has a wonderful wind resource. This is a place that could definitely benefit from wind energy. We're continuing to develop the systems. The challenge of reliability is really important when you're so remote. If you're in a village like this in the middle of winter, you don't want your power going out, so it's really important that these systems can perform well. We're almost there, hoping in this coming summer or the summer after to have our first ongoing, continuously running wind turbine systems in the village.